Now let's do a few more examples of double identities, double angle identities. So if we say that if sine of alpha is 3 over 5 and cos of alpha is 4 over 5, minus 4 over 5, let's take it like this. It's minus 4 over 5. They want you to find sine of 2x to alpha first. Okay, it's very easy. Sine of 2 alpha is equals to 2 sine alpha cos alpha, right? So you are given with the values of sine alpha is 3 over 5, cos alpha is minus 4 over 5. 2 3s are 6. 6 multiplied by 4 is 24. Since there is a minus sign, multiplying here once, so minus 24. And 5 multiplied by 5 is 25. So this is my result for this thing here. Okay. Now I will use one more example to explain further. So for example, this is a good example. And okay, now for example, you have to, without calculator, you have to do this question. Okay. Using the exact value of cos theta, show your sine of 15 degrees is 2 minus under root 3 over 4. Very good question regarding double identities. Say they are saying that you can use the value of cos 30 degrees and then you have to prove that your sine 15 actually is equals to this particular thing. Okay, one thing very important in SL, you have to memorize your 0 degrees, 30 degrees, 60 degrees, 45 degrees, 90 degrees and 180 degrees. Very, very important. Okay, you should know all the values for sine and cosine for all these angles, and you should know them in form of a fraction. It's better for you. Okay, because in trigonometry, if you know in form of a fraction, you can easily deduce that what is the hypotenuse, what is the opposite, what is the adjacent. So it's very important to know the exact fractions of these particular angles. So let's start. Let's say it's a cos of 30 degrees. Can I write my, let's say cos of 2x is equals to what? Is 1 minus, because I want to know the know sine and in terms of cos, right? So we have this double angle identity where cos of 2x is actually equals to 1 minus sine square of x. These formulas you can find in like your formula sheets as well, but it's better to memorize because it's good if you'll practice more and more. It's better for you to memorize it instead of just looking into the formula booklet all the time. All right, can you write cos 2 multiplied by 15 degrees? Yeah, why I'm writing this particular thing? Because I can use cos of 30 degrees, right? And 2 multiplied by 15 is what? 30 degrees, right? So, and here I just want to use 15. I'm just saying that my x is 15. My sine square 15. Okay? I'm just saying that my x is actually equals to 15. If I put x equals to 15 degrees in this equation, so can I write that because it was cos of 30 value I can use? So cos of 2 multiplied by 15, which is equals to 30. 1 minus sine square of 15, which I need to find. Sine of 15 I need to find. Okay? So always concentrate on the question, that whatever they have provided you, how you can use that in your question. Okay? All right. So what is the value of cos 30? What is the value of cos 30 degrees? It is under root 3 over 2. Okay? Under root 3 over 2 is actually equals to 2 minus, 1 minus sine square 15. Okay, till now. I just have placed, instead of x, I am writing 15. Why I am writing 15? Because I can use cos of 30 degree value to calculate the value of 15. I'm using a double angle formula so that, because it's half and half. Concentrate on the question. They are doing half and half angle, 15 here and 30 here. So I have to use double angle identities. Okay? Okay. So since 2 is dividing over here, so if I bring this 2 over here, it will multiply, right? So if I bring 2 over here, it will get multiplied with the whole equation. So can I write as under root 3 is equals to 2 multiplied by 1 is 2 minus 2 multiplied by this whole thing is 2 sine square 15, right? I can write it like this. Okay. Oh. Okay, one mistake. Students, listen. It's 1 minus 2 sine square x. Okay? The formula is 1 minus 2 sine square x. So just put 2 here. Now 2 multiplied by 2 is 4 here. Okay? Let me repeat again. A small mistake I did. Cos 2x is actually equals to 1 minus 2 sine square x. Okay? So just put 2. Rest it's exactly the same. Okay, I just multiplied this 2 with this 2 to get a 4. Now my equation is under root 3 equals to 2 minus 4 sine square 15. Okay, now what I can do is that I can bring all the numbers on one side and keep this sine thingy on an other side. So I can write this as under root 3. I don't have space. So where? So this equation I am writing. So under root 3, this 2 has a positive sign here, right? So when it will go over here, it will be minus. So minus 2 equals to 4 has a negative sign. So minus 4 sine square 15 is left. Minus 4 sine square 15 is left here. Okay, so let's divide this minus 4 over here. Since it's multiplying over here, if I'll take over here, it will divide. So minus 3 minus, under root 3 minus 2 divided by let's multiply both sides with minus sign. So I can write minus under root 3 plus 2 over 4 equals sine square 15. Just multiply it with minus sign. So since this was plus, so plus multiplied by minus is minus. This was minus, minus multiplied by minus is plus. And this minus multiplied by minus will again be plus. So that's why I just made it positive. Okay, fine. Now let's rearrange this. Let's take positive 2 here, negative under root 3 here, here. Now this is square. Let's take under root on both sides. So under root 2 minus under root 3 over 4 equals to sine of 15. And this was what they actually wanted us to prove. 2 minus under root 3 over 4, and we proved that yes, it is equal to this. See, it's very simple. You just have to use your brain in the right direction, that what is the question and which identity I have to use in this question. So always and practice will make you even more perfect. The more you will practice, the more questions you will solve. You will come to know that, okay, fine, this question I can do it with double identities. This one I can use with simple identities. So